Welcome to solverfy.
So here we know that the velocity is going to be equal to the square root of the gravitational constant times the mass divided by the radius, or the distance. And here v squared is going to be equal to gm over r. So we can say that this is going to be equal to the gravitational constant times the density times 4/3 pi r cubed, and then divided by r. So we simply substitute in for the definition of mass, the density times the volume. And so we know that v squared is now going to equal 4 pi r squared times the gravitational constant times rho, the density. And so the radius, so the distance in this case, would be 3v squared divided by 4 pi g rho, all to the 1/2 power. And at this point for part A, we can solve. So r is going to be equal to 4 pi times 6.67 times 10 to the negative 11th times the density, so 2,700 kilograms per meter cubed, and then times 3 times 22 meters per second squared, all to the 1/2 power. So this is going to equal 25,330 meters. And then for part B, we know that the velocity equals 2 pi r divided by t. So the period is simply going to be 2 pi r divided by v, the velocity. And we can solve. The period is going to be 2 pi times r, which will be 25,330 meters, which we just found, divided by the velocity again, so 22 meters per second. And we find that the period is going to be 7,234 seconds. This is approximately 2 hours. So that would be our final answer for part B. That is the end of the solution. Thank you for watching.